Ladies and gentlemen, hello and welcome to today's Partner Web Conference. This is Fast Track Dynamics 365 for Finance and Operations Tech Talk. Today's topic, Performance Troubleshooting Tools for Dynamics 365. My name is Janice and I'm going to be your moderator today. We are broadcasting this web conference through Teams Live events and the audio can be heard through your PC speakers. Today's web conference is being recorded on behalf of the Microsoft Corporation. If you do not consent to be a part of a recorded session, we ask that you please disconnect now. Attendees may access the web conference recording within 24 to 48 hours via the same registration link that was used to attend today's live broadcast. If you have questions for the presenters or need support, you can turn on the Q&A panel by selecting the question mark icon located in the upper right-hand corner of your screen. We do have presenters standing by to answer your questions throughout the session. Now, moving on to the presentation, presenting for us today from Microsoft, we have Davy Vliegen, Jeff Liu, and Markus Otte, who are all Senior R&D Solution Architects. So without any further delay, Davy, over to you. Welcome and thanks for joining us.
Thank you, Janice, and welcome everyone. This session is about performance troubleshooting tools for Dynamics 365 for finance and operations. So as this is a performance session, let's not lose any time and let's start the session. Typically, when users complain about performance, we get, and you know that probably, a very descriptive message, something like Dynamics 365 for finance and operations is always slow, the system slows down, the browser hangs. These are typical messages. Now, how we start from there, we have to start somewhere a tuning process. And the first step here is to try to narrow it down. So we have to find out somehow where we spend most of the time, and we have to focus on these areas to optimize the performance. Things like few or many calls, are we blocking, running or waiting, come into play. We troubleshoot the issue, and then we come to a sort of a mitigation step. This can be like a temporary mitigation or already a final one. A fix will be created, has to be tested, of course, and finally it will be deployed into production. Remember that performance tuning is an iterative process, and it's also something that has to happen during the entire product lifetime. It's also important to highlight here that performance tuning also in Dynamics 365 for finance operations online is a joint effort between Microsoft and the operating team at the customer side. So this operating team can be operated by the customer itself or a third party, but it's important to highlight this. The reason why Microsoft is committed to provide a very scalable platform. So we have the Azure infrastructure on this slide, which is, in general, consists out of servers and databases. And on top of that, we run our standard solution. The standard solution is our platform and our application. So these are the blue building blocks. So far, so good. But then during the project, we add additional building blocks. We access Dynamics 365 for finance operations using different devices, different browser types, maybe even unsupported browser types. There are customizations on top of it in each and every project, and we also make use a lot of times customers of ISV solutions. Then we have the data who comes into play, and this data constellation is as well different from customer project to customer project and can lead to different performance issues. Then there's the integration. Integration have a huge impact on the performance as well. And we see a lot of times wrong design of several integrations, which can lead to serious performance issues. The same for analytics and reporting. Each and every customer probably will use Dynamics 365 for finance operations in a slightly different way. So processes and operations are different. And then in the end, we have the users. And you all know users can do a lot of good things, but also one user can bring a serious performance bottleneck into the system. Let's look at some common performance symptoms. So of course, this is a high-level summary, and there could be more symptoms, but these are the typical ones. So one example is all interactions with the system are slow on all workloads. So if this happens, probably we have to start with checking the network and also the infrastructure, the environment measures. For this, we use a tool which is called LCS Environment Monitoring, and this tool will be demonstrated in this TechTalk session by my colleague Jeff soon. Another typical symptom is my particular process is slow. an interactive workload. So what would we do then? If we can already reproduce the issue, then of course what we could do is we could use tools like Performance Timer, which is a built-in tool in Dynamics 365 for operations, for finance and operations, or we could also already take a trace with Trace Parser. Both tools will be demonstrated as well today by my colleague Markus. If a specific process is slow, but only at specific times of the day and an interactive workload, we again have to start with checking the environment monitoring, the environment measurements, because maybe there is at that moment a heavy batch or another workload like an OData integration running at the same time and is having a big influence on the interactive user experience. Another symptom that we see often is a batch task, which is taking ages to complete. When we have this, the recommendation is to start from the batch history table, drill down to the batches, drill down to the specific task, see where most of the time is spent, and start tuning there. The tuning process is then similar than already explained before. We could also take a trace at that moment. Traces should be kept small because for the ease of troubleshooting and analyzing. So probably you will not trace then the entire batch process, but you do short traces at several intervals and you try to discover patterns and improvements in code and in queries. And then the last example here is integration, but another system is slow. We see this a lot. First of all, we also have to identify then if the issue is coming from Dynamics 365 for finance and operations, or maybe it's coming from the other system we integrate with. Once we discover this, we can use similar tuning techniques. We also always have to question the integration design, which could be maybe a wrong design at the beginning, which can lead to serious performance issues. And whatever tuning we try to do, we don't come to an acceptable performance. Let's look now at the tools. I try in this slide to give an overview of the tools that are available today. And I split them up between Tier 1, which are typically your dev boxes or demo environments, Tier 2 plus, so 2, 3, 4, and 5, which are the sandbox environments, Multibox and SQL Azure. And then in the end, you have the production environment. Now, LCS environment monitoring is the main tool, I think, which we a lot of times start from, definitely for production, and can also be used in Tier 2 plus environments. This tool will be demonstrated soon by Jeff. Another tool I will highlight later after the demonstration is LCS issue search and tiles. Then Markus will demo Dynamics 365 tracing and perf timer tool and F12 browsing tools, typically inside the browser. These tools are not new, definitely not the tracing, but still there are a lot of questions and people not always knowing how to use or how to analyze a trace, or how to start analyzing. Query Store will be highlighted at the end of the presentation and is a useful tool. Query Store will also be used in the backend for production systems, but cannot be queried directly. But of course, through LCS environment monitoring, we make use of Query Store as well. Windows Performance Monitoring is not part of this TechTalk because it's just a standard Windows Performance Monitoring tool everybody should be familiar with. The Performance SDK will be part of a separate session, TechTalk, which we plan end of January timeframe, 2019. So we will not go deeper in this session into this tool. And at the end of the presentation, I will still highlight Optimization Advisor tool. There are other third-party tools that could be used, like, I don't know, PSPing, Fiddler, and many others. The one that have an exclamation mark are the tools that are still available on the Tier 2 plus environments, as long as we have RDP access. Whenever we would change this and we go to more lockdown of these environments, we of course have to make sure that there are other ways to access this performance data. Now, let's move on to the first tool, which is LCS Environment Monitoring. This tool, you start from the Environment Detail page in LCS, and then you scroll down to Monitoring Diagnostics, and there you can find the link to Environment Monitoring. What do we have in LCS Environment Monitoring? You basically have three tab pages. One is the activity, one is the health metrics, and one is the SQL Insights. Activity monitoring gives a timeline of the system usage, and here you can see typically things like DTU, how busy is the SQL Azure server in the backend, and you can also drill down to specific areas in the role telemetry. We also have some pre-canned queries. Then we have the health metrics. health metrics, so critical metrics such as SQL connection trends, but also CPU and memory usage, for example, of an AOS. Things like you would use, for example, Windows performance monitoring in the past, but now because you cannot access them directly on a production system, you can use this top page instead. Then you have the SQL Insights, which is the most popular one, I think, and there's also a lot of changes recently. So SQL Insights we already had before, and I think on this view here, these two are now moved to the end. But performance metrics and index analysis gives you more like an aggregated view on a longer duration about how indexes and queries are used. Next, we have now recently released the live view, which gives you the current DTU and also your current executing SQL statements and blocking statements. This is really useful in a live situation to get a view on why is my DTU high, which statements are executing. We have some additional queries in the queries area where you can typically do things like, okay, I want to see my current blocking tree. Once you have discovered the performance issue, you want to maybe go directly to a mitigation step. Several actions can happen. Some of the popular actions are, for example, create a specific non-clustered index, or non-unique index. Or you could also, for example, end the SQL process if you're in a critical situation. Now for LCS environment monitoring, there's some additional readings you have here. They're all on the doc sites. I want to highlight the query cookbook, which has for each query and action of the SQL Insights a very detailed description of what it's doing. So I definitely advise here to have a look at it. So now we will have Jeff, who will give a demo around LCS environment monitoring. Jeff, it's up to you.
Yeah, thank you, David. Let me share my screen. Sorry, let me, I need to share my another desktop. 1 second. Here we go. Okay, so this is the environment monitoring. We can find from the LCS. So basically, you go to the LCS and go to your environment detail, and then you go to the monitoring page. You will find that environment monitoring link in there. Once you click in there, you will get into this page. So as Davy already quickly walks you on the different tab. So let's start from the tab by tab. But I want to highlight for the second tab, that's healthy metric, which which gives you some of the measured data about it, like a CPU, memory, those stuff. But this tab is already available for the production environment from the compliant purpose. So if you do it in the sandbox, then you will not able to see you will not able to use this tab to view those measured data. And when you do the performance testing, you probably want to take some other tools like performance monitoring, like performance counter coming from the Windows to capture those data. Okay, let's now focus on the activity page. As the David mentioned in early, that activity tab page should give you an overview about how the system utilization looks like, or how busy the system is. So in this case, I don't have the real life environment, so it's not that crazy busy, but I want to showcase the some of the tool available in there, so you can get the concept and eventually you can apply to your implementation project as well. So in there's a different tab in here. So the first tab is the graph to show you about the activity and the DTU utilization. Also, it gives you some of the idea about this. If you have multiple box environment, especially in the sandbox, if you have the a few of the areas or 10 of the areas, then sometimes you only need to focus on some of the specific box. Then you can enable and disable to quickly to exclude some of the environment you are not care about at all. Then it will give you some of the idea where to focus, especially from the SQL perspective. This is some of the area you probably want to take pay some attention if you see some of the spike happening in the SQL side. It also allows you to zoom in and zoom out. So basically, if you zoom in, you can see, okay, you can basically say, hey, this is the area I want to stay focused to understand, hey, what activity happened during this period, and then get into detail. And okay, we go back to the second tab. This is user role. So user role basically tell you, okay, what kind of the user distribution happen in the different upper box, and also give you some of the quick idea how heavy that user roles look like. And the third tab is basically tell you from the activity perspective. Then activity, what activity is. So inside the dynamic 365 operation, whenever you open a phone, whenever you click a button or run a report, that's one of the activity. So activity give you a more granular view about the particular of the single activity and how heavy it is, and whether is there any of the thing you need to focus on. For example, whether it's occupy a lot of the, if you from bar chart perspective, if the occupy a lot of bar chart, then you need to take a look at why it take so many of the so long or so many of the resources to execute it. Then in the bottom, it will be the user activity. So user activity is talking about those activity for the interaction sessions. So basically, you use the browser to interact with your FNO. Then each of the browser will have the some of the session. Then how to find those session ID. And this is also some of the good practice that you can apply when you're doing the UAT or during your testing. And whenever you people come to you to complain about, okay, there's some of the issue, no matter it's a performance issue or it's an error or functional issue, then you want to do some of the troubleshooting. If you want to use the environment monitoring, then one of the key information you need to understand, hey, when this activity happen and what's the section ID, then how can you find it? Then just go back to the FNO, get the user to click on that smiley icon, and then you will find those browser session ID and the time span, and you can also find in which particular of the AOS the activity is happened in. Yeah, and if you go back to the user activity, basically this is the user's GUI ID. So inside the FNO, if you go to the user's screen, you will find there's a telemetry ID, and that's the GUI ID showing here. And due to the privacy reason, we cannot show the user's ID or user's name in here directly. So we use the telemetry ID. So you need to do some other mapping in order to understand, hey, which exactly user this session belong to. Then after a particular of the browser section, under it is a bunch of the different activity. And this is user activity actually help you to understand what kind of the operation performed by a particular of the user or particular of the session. And by looking into this grid, it gives you some of the idea. So basically, it help you to understand the high level of the workflow of the particular of the section. So for example, in this case, if you go through each of the steps, you will understand, hey, basically this user come into FNO, go to the default dashboard, and then click on to the switch legal entity, drop down and change legal entity, and later you just go to that sales order page and then create a sales order. So besides the process, it also give you a list of the activity, and you take advantage of this activity ID and use the predefined crystal query we're going to demo and going to showcase later, and to find more detailed information in there. Besides the activity ID, besides the the high level of the process, there's also some of the information can help you. It's not just for performance, it's also help you to do some of the troubleshooting from the feature perspective, whether is there any of the message sent back to the user interface, whether is there any of the error or warning happened that probably end user not aware at all. So for example, in this case, in the bottom, you actually will find there's some of the error happened. And this actually can help you to find, because sometimes will user just come to you, hey, this function is not work. Then why it not work? Because is there any of the error happens? So this can help you to understand, hey, what's exactly happened to that particular session. Then you can go back to have the conversation with the customer together. in the meantime, to also pay the attention to the time span. If you look into each of the activity and check the time difference between the activity, you can actually have some of the idea, okay, which activity actually is the heavy activity, right? So if we go back to some of the session back, if you go through this, some of them, you will find a couple of activity actually take a long time, for several seconds or tens of seconds. Then eventually you will understand, hey, this is a particular activity I need to stay focused on. Then you can get the activity ID, and then we can go to that view row log to use some of the predefined crystal query in there to help you to understand the detailed information behind the scene. So this is the view detail log, and when you click on here, it depends on which predefined crystal query you select. Some of them will use the start time and end time. Some of them will just search the entire database against your talent, and some of them, there's a bunch of the different predefined crystal query, and for the different purpose. My suggestion is that you play along with the system, and then come back to the inbound monitoring, and then use this predefined crystal query to understand the query itself and to understand what kind of data you can get. So basically, the bunch of the predefined crystal query in here can help you for the different purpose. So we will demonstrate some of them to give you some of the quick idea. And one of them is that I want to quickly show is that the user login event. So let's say, for example, one of the example in the early slide that we mentioned is, hey, sometimes the system is slow. And this is probably some of the crystal query you can use. Quickly look into, hey, by which particular of the time span, and you can look into all the activity happening in the system and try to understand, hey, which particular of the activity actually take a longer time. So if we look into a list of this activity, so if we can see some of the last activity actually take several seconds. If this is probably some of the activity we need to pay attention. Then once we get the browser activity ID, then we can go to the next predefined crystal query, which is that all event for browser section. So you basically paste in that browser section ID in here. It will give you a full list of the activity under this particular of the browser section ID. It will give you the activity ID, time spent, and some of the action taken. And also you can see, for example, in this column there's a duration in there. You can quickly understand, hey, which under this particular of the browser section, which particular of the activity is the bad guy and need to take a further look at. Then you can grab this activity ID and use another predefined crystal query called order event for activity. And this is looking for the particular of the activity. For example, a button click or a phone open or a record creation. So for this particular of the activity, it basically tell you, hey, they are trying to doing some of the sales order creation. So if you play along this output, and if you take advantage of these or show column option, which allows you to add or remove the addition of the column from the telemetry data, if play along with, then eventually you can count out some of the data like this. So it tell you when, what kind of activity taken, which measure, how long it take, which class, which phone, which control, which command is executed. Even can tell you, hey, which company and what kind of the user role when the user performs such activity. Okay, there's a lot of the good message, a lot of good data sitting in there and waiting for you to dig into for the detail. Okay. And the next one that I also want to call out is that about the old log. So which means that sometimes, for example, I have some of the use case. For example, a couple of days back, one of the customer came to me and hey, I saw some of the snow query, but I have no idea which process, or I have no idea which customer, which user actually trigger it, then what will happen to this case? Because the admin try to dig into it, and how can LCS help them? So the one way is that if they can look into some of the Snow query, for example, and the Snow query actually can give you the call stack. By the way, for Snow query is another of the predefined coastal query is right in the FNO site. Whenever there's a query, executes longer than I think it's 100 millisecond or 150 millisecond, then we will create one of the entry in our terminal database. And then besides capture the SQL itself, we also capture the call stack. So with that call stack, it helps you to understand, hey, which process trigger this slow query? Why is slow? Because if you look into some of the average, if you look in some of the, execution count or utilization, you can understand whether it's generally slow, is just a particular one is slow, or those idea. And with the call stack, you can nail down, hey, which particular of the table, class, form, or even measure trigger this particular of the Snow query. Back to our previous use case. So once you get the call stack, you can go back to use the all log and putting some of the keyword in here. For example, in this case, I know for that previous process, I dig into and quickly understand, hey, there's some of the actually happening along the packing and picking process. Then what will happen to the to those Snow things? Then I want to quick look at, hey, whether is that the picking button actually cause some of the performance issue, and I try to understand which exactly of the user trigger that process. Then you can go back to use the all log and put your keyword in here, and then search the terms database against this 10 span window. Then quickly the system will give you a list of the output, and then you can also take advantage of the show query and add additional column, for example, the user GUIs. With that user GUI, you are able to identify which particular of the user kick off this particular of the process. Then you can go back to have some of the conversation with the user to get more detailed information from his activity, and then drill down in the detail and find some of the bottleneck eventually, and then conduct the optimize the entire process. Okay, and this is the environment monitoring. And that Davy mentioned that recently we also enhanced the SQL Insight. So SQL Insight, the first view is the live view. So what live view does is that it just give you idea, okay, what's the current DTU, what's the current execution SQL plan, and if there any of the SQL blocking happening in the system, then what's the SQL what's the blocking trend looks like? Who is the blocker? Who is the leading blocker? Who is the blockage statement? So to showcase that one, I'm going to create some of the blocking and also combine this live view and the action in the SQL Insight to quickly demo how to kill a leading blocker to unblock the entire of the blocking trends. So for sure, I'm going to create some just create a blocking to simulate the sorry, let me. Okay, then I just come in here. Also want to place this just want to confirm this sales order. I use this way to simulate the concurrent situation. Okay, that is executed. Oh, actually. Good. So we can even, as a confirm, and let me just post. Oh. Let me refresh it. Once you refresh it, you will see the current execution SQL, and you will see the blocking statement. You will find, hey, this is the leading blocker, and this is the SPID blocked by the leading blocker. So for some reason you believe, okay, there's no moving for the leading blocker. You want to end that process in order to get the remaining process moving forward. What you can do is just find that leading blocker, copy the SPID, and then go to the action pane, action tab. In there, we will have a called end the SQL process. Then we enter that SPID, and we provide a reason why we want to kill it, because it caused the blocking. And then we confirm it. Once the execution complete and the leading blocker, ended successfully, then we will go back to the live view, refresh it. Okay, we can see the all blocking statement is gone, and then this operation complete. So this is just a quick demo of one of the action and a reason of the enhancement for the SQL Insight. Of course, we also have another tab called query. There's a bunch of the predefined query, useful query in there to allows you to find the current blocking, current DTU, current running query, or some of the expensive query. You can also use some of the predefined query, for example, to get the SQL index fragmentation detail. With this detail, you probably want to do some index rebuild in the production. Then to do that, you probably want to open the support ticket and tell the DSC team, hey, this is the bunch of the table and index I want to rebuild. And of course, you need to provide the downtime as well. In the end, I also by the way, I forgot to mention, besides the index rebuild, normally from the SQL admin perspective, from time to time, they probably want to rebuild some updates of table statistics. But as some of you may know that in F&O right now, we have some of the monitoring and cell hits daemon process running in the backend. We call it watchdog. For the watchdog, we are handling that update static periodically. So that is handled by the watchdog and by Microsoft already. But the index fragmentation rebuild is still one of them. It's not yet handled by the watchdog. And you probably want to look into some of the fragmentation data and then ask the Microsoft to build the index for you. The last tab I want to highlight is that the performance metric. So basically, this is the data return from the query store inside the SQL, and allows you to based on the define the time frame to inquiry to get the the like slow query those information out, and also it allows you to download the query plan you can first analyze. And in here, you can also quickly understand, hey, for some of the long run query, what's the exactly of the issue caused that long running. For this case, probably it's too much waiting. Probably you will need to dig into whether it's really that because you're waiting for something, or actually it's a block by someone else. Yeah. So I think that's all I have for the LCS environment monitoring. Davy, back to you.
Thank you, Jeff. So let's continue. So one more tool of LCS I would like to highlight is issue search and also the tiles. So LCS issue search, this you can just find on the LCS homepage, get started, issue search. And the other one, if you go to the environment detail page, you have the tiles. Why is it interesting in terms of performance troubleshooting? For example, you're in your analysis phase and you found a specific issue, specific piece of code that is running slow. You probably would like to find out if there already a hotfix exists, or if there's at least somebody else reported the same issue and there is maybe an open support ticket, or there is a limitation in the design. Things like this are very useful to search up in LCS issue search and tiles. One quick remark regarding the tiles going forward. So if you already are in version 8.1 and moving forward, there will be only a single tile, only a single hotfix type. We will not go deeper in this session on this, but I really encourage you to look at the tech talks regarding Microsoft Managed Continuous Updates, which goes much more deeper into these areas. Now, the next set of tools where Markus soon will give a demo about are the Dynamics 365 trace and the trace parser tool. The tracing itself, so let's assume that you have an isolated performance issue. So you have discovered a certain process that is slow. So preferable in a test environment, you're going to do tracing. In a production environment, you could trace as a last resort, but you will have a lot of noise and you have all the sessions from a specific AOS in that trace, correct? And you maybe have to find out on which AOS your repro will be running on. So a lot of challenges, that's why it's better to do it in an isolated environment. Make sure that you have a warm trace, so that means that you already reproduce it once and then you do a second try, so you don't have all the metadata noise inside your trace. Keep traces small, so don't take traces which go to the limit of gigabytes, because they're very difficult later on to handle and to analyze. It's better to take shorter traces and then analyze and search for patterns and try to optimize from there. The tracing is controlled by a security role, which is the system tracing user. And more information you can find on these doc sites, but also there is an interesting blog from the Microsoft support on how to enable this tracing and start and stop and automate it from Windows Performance Monitoring. Then to analyze the traces, we use a tool which is called Trace Parser tool. This is pre-installed on each and every development environment, so the tier 1 box dev environments. So it's very useful as well to do the analysis there, because there you have also your source code, and this is probably needed when you do analysis in the traces. Then the other tool that Markus will show you is the performance timer and also the F12 browsing tools, which depend from browser to browser type, correct? But the performance timer is a built-in tool. It's a very lightweight tool inside Dynamics 365 for finance operation in your web browser client. So if you have the URL and you add to that ndebug equals develop, there are different options. There's also ndebug equals true. Then you will come into a different view, which Markus will show you. I mean, it's the same view, but on the right top, you have some perf timer. And this is very useful, for example, if you have a user complaining performance is slow, and you can activate this, and then you can see where most time is spent, because there's a clock on the client side, a clock that measures on the server side, and the difference in between, that is then the latency over the line. It's important to highlight that this in production, you have a little bit less detail on the server details, on the server calls, but it's still very useful to know, is my main bottleneck the client network, or is my main bottleneck the server side? The F12 browsing tools, they can also help if you are not, or if you're running in debug mode, you can still use on top of that the F12 browsing tools. And it could also give you a good idea on where time is spent, and also show the network package speed over the line, for example. So now Markus will demonstrate the tracing, the trace parser tool, and very quickly, I think, the perf timer. So Markus, to you.
Thank you. Let me share my screen. And let me know when you see it.
Yes, Markus.
Thank you, Davy. I'm here connected to a browser session, which is outside of my VM, where I have also a connection to. So this is a remote desktop connection to my VM. We come to that later. So as Davy mentioned before we start tracing, we should ensure that the scenario is at least executed one time. I also would advise you to, if you do the tracing via the UI, so in the browser, then you should try to do this one time before you actually want to trace your scenario, because there is a pop-up blocker that might prevent you from downloading the file afterwards. The most useful information we usually don't get from the users is on which system the problem was, to which time frame, with which user context. So this is the way how to get the session information, and I usually make a note of those to ensure that I have them available. And this is also what I would ask the user if there is any complaint about performance. So then we have the icon here to start the trace. Before you start a trace, you give it a meaningful name. As soon as the stop trace button appears, the trace is running in the background. You repro your scenario. That might take a couple of seconds, whatever you do in your scenario. When the scenario is done, you hit stop the trace. That might take a little bit, and then you actually start the download. And this is what I would always recommend, to download the trace files to ensure you have them either for direct analysis or later on. This is the pop-up, and if you have a pop-up blocker in your browser, it will actually prevent you from downloading the file. So as this environment is currently hosted in US, I will not download this 28 megabyte because it will might take you some time, like 5 minutes or so, to actually download it. I prepared that. But this is the thing you have to keep in mind. So whenever you want to trace something, you should download the file afterwards and be patient. It takes a while, but then you have the ETL file locally available. That was a test I just did before. So, and that was 120 megabyte even. So if you zip them, they compress quite nicely, and then you can move it around. So that was one way to collect a trace for a very short scenario. I will just cancel the download here and close that window. Another way, another good way is to collect traces is when you have the chance to actually connect via RDP to the environment. Then you have the possibility to do the tracing, so-called server-side tracing from Windows ETL. So you use the performance monitor. If you don't know the tool, it's just if you type perfmon in the search bar, and don't do a typo, it should show you. So this is the performance monitor, and in the data collector set, user defined, you can easily create a new data collector set. I will just demo shortly how to create it manually. So you use the event trace data next, and then you need to add the dynamic specific trace information. It might take a second until this is populated. Once this is prepared, you just scroll down to Microsoft Dynamics AX. There are 3 things you need to check or you need to add to your session. This is all described in a blog by a colleague, so I will just cancel here for the matter of this purpose. I predefined this Dynamics 365 FO trace. So that has been created in the procedure I just described. So if I just start the trace here and then go back to my browser session and do again the repro. Going back to my VM, stop the browser session. That was a trace I did. I tried to isolate the test case as much as possible to keep the trace files really small. The trace files are locally stored. And here it is. I usually take those trace files and collect them at a, let's say, centralized space to ensure that they are at a centralized place, so to speak. Again, give it a meaningful name before you import. So now you collected a couple of traces and you want to analyze them. One tool to analyze them is the trace parser, which is pre-installed on the dev boxes, as Davy mentioned. So if you type trace, you get the trace parser. When you open trace parser the first time, you need to create a database. So I'm also connected to my local SQL server here. This is my local SQL server. I have already a trace parser database, but I just wanted to showcase you. So the first thing is that you, on your local system, initialize a new database. That's fairly quickly done. And the next thing you do is to import the trace. I'm just using the last trace, which I'm going to import here. As soon as this is imported, or I will, for the matter of time, just shortcut a bit, open the trace parser a second time. Use the other trace parser database where I imported already a couple of files, and use this one here. So first analyze the trace captured from the UI. And as you see in the naming, this is the file name where the imported trace starts with. So it's really valuable to have that renamed before you import. Otherwise, you might not remember which trace was for which purpose. So I will just open the trace. With a new trace parser for Dynamics 365 for finance and operations, there has a new view has been added, this timeline overview. I don't find it that useful, so I usually, the first step is to find the sessions. As this was an isolated environment, I only have a few sessions, but you can isolate or identify your session which you want to look at either by the username. Sometimes this username is not populated because the user is probably from another AD. It's just added to your local environment as a user, and then either trace parser or the tracing tool cannot identify the username. But what you always get is the session information, and within the session information you have also the username. Going back to my session here, so that was the session information I just copied. So my username starts with 60F3. Going back to the trace, you see 60F3 in the brackets. So this is my session. And for other traces, you potentially have a long list of sessions. So this is the first task, to identify the right session. Then there are several tabs here. I usually start with the call tree because it gives you a nice, let's say, overview, what has happened. Color coding is currently colored by inclusive milliseconds. The other interesting column is exclusive milliseconds. Also database calls, have a look at those, the database time spent. I usually start with filtering, and the value I enter depends on how long was my trace. If it's like a minute or an hour trace, then of course the value is higher. But to get an idea where the most money goes in the trace, or where the most time is spent, you can just filter, and then you go down and identify the area you want to look at or where the most time is spent. And this is the area where you see the source code, and this is where it makes sense to have actually the trace analyzed on an environment where you have the same version, because you then you can easily see, okay, this is the call stack I'm currently executing, and this is why, because I'm using here this if statement and so on. So you can easily go down and see what is the route, where did I spend most of my time. If you have very complex traces, you also can use a nice feature which is called create a subtrace from this node. So you get a subtrace created in your trace parser database with just the 2.6 seconds, and usually if I use this feature, I open this in a second window to ensure that I still know where I left off, so to speak, with a deeper analysis. Then you take this one here. Again, either go to the call tree, or as you can see, this is just isolated the 2.6 seconds, or you directly go to the X++ tree. Nice feature here is the filter feature. So you can just search for everything which has an init in the method call, just as an example. And if you click one method, then you also see the call stack below, and again the source code if you execute the trace parser on the environment where you have the source code as well available. Going to the SQL tab, this is similar to the X++ tab. It's a page where all the SQL executions or the tables are displayed, so you can toggle this. You can also filter here, so I know I did something with vent table, so I'm just filtering those. Then you see all the SQL statements where vent table is used, or you search for update, just as an example. So no update statement in my trace here. That was the way how to actually analyze traces in trace parser. Of course, that was a very small sample. I'm trying to close this here, and I'm trying to close the trace parser, open it again. As you can see here, you also can do longer traces with this server-side tracing, where you, for example, trace parts of the master planning. So you either automate this by the pathmon feature, which you can configure in the properties with stop conditions, which I put to 1 gigabyte, and then I restart the data collect when it hits the limit, so you get a series of files. Just for your knowledge, you lose some transactions in between, but still it's valuable to see what is the execution. And then if I have a series of trace files from the same process, I start with the first, then I continue with the second, and then as soon as I see, okay, the next one is looking like the one before, then I go to the end of the process, analyze the last trace part, so to speak, and then going back a bit until you see similarities to the traces before. And then it really depends. There is no silver bullet or a golden rule for every trace. It really depends on the trace and what you tracing, so it depends on the scenario, it depends on the data composition. And then I'm just opening a probably larger trace. Will take a second. I hope not that long. If you then isolate a query which was slow, you can also go back to query store. So I enabled query store here. This is just one view out of query store where you can see the overall consumption. It's from the AXDB. So as soon as you execute test cases here on your test environment, you can also use then the query store to look at the, let's say, top resource consuming queries. Every of those views can be customized. So yeah, it was already there. So going back here, so you can configure to which time frame you want to look the data, you want to slice and dice, and also what is your is it duration, is it CPU, is it logical reads, different things you want to look at. So just a side note, how to go further if you isolated an expensive query during the MRP, just for instance. So I'm looking for an MRP execution with a lot of SQL statements. Takes a second until he synchronized the session. Just bear with me. Now going to the SQL tab. And then, of course, yep, there are some. So in those tabs where you see overview, I usually sort by what are the calls that have been executed most of the times, what are the calls that took a lot of time, either in total or in average. Because and then it depends, of course, we start at the areas where we have a lot of time spent. So that was kind of taking trace from two ways, analyzing the trace. The other thing I wanted to showcase, just a second, was the perf timer. Davy mentioned that you just need to add the perf timer to your URL. And then just be aware, if you add the perf timer to the URL, there is a performance overhead just caused by the perf timer. So whenever you test something in the system afterwards, it will be a little bit slower than usually. What you get here is this new visualization in the area. And then if you click on it, you can go down and see how the time spent for the entire call is split off. The challenging part with the perf timer is a bit, so if you have UI changes, then as you can see, this is moving a little bit around. So and only the last synchronization or actualization of the UI is captured in the perf timer. This is a bit the challenges, but this depends on the environment. So I'm now connected to my dev test environment. That means that I'm still able to see the server calls. And also, if you see here 1.2 seconds, something like the longest query. Yeah, this is how a query looks like in finance and operations. So this is a way how quickly to analyze what is happening. I remove this now. The second, the perf timer was built in Dynamics 365. One Dynamics 365 independent tool is the perf timer. You hit F12 in any browser, and there are two areas which helps you with analyzing performance. One is the network tab. So you see what is going over the wire, so to speak, and where does the most money goes, or where is the time spent. You can start and stop and store those information. I would stop that now to not overwhelm it. The second part is the performance, and this is, you can start it again, and then I will just reload my page. As soon as you run through your scenario, I would again try to isolate as much as possible. I hope that's coming up now, and I don't have, yeah, voila. So as soon as you stopped, it's automatically kind of analyzing and providing you a nice report, which then afterwards can be stored or exported. I think I showed everything I wanted to show. Giving back to Davy.
Thank you, Markus. Let me share back my screen. Okay, so sorry to go a little bit over time. We are about to finish up in a few minutes. The next tool I would like to highlight, and I'm happy actually that Markus already demonstrated as well, because at least you already have seen the query store now a little bit. So query store is used to do analysis on SQL queries, expensive queries. So typically you can see things like the runtime stats and the wait stats. You can do an index analysis. So when you saw the environment monitoring SQL Insights tools, it also on the back end will query the query store on the production environments. So each production environment has query store active, and you can also, of course, use it on the tier 2+ boxes, and you can also use it even on your tier 1 dev box on a SQL server. So how to monitor the performance by using the query store, Markus showed a very little bit. You can see more on docs articles, specifically it's not specifically for Dynamics 365 for finance operations, but it is very general. So there are also some interesting docs articles about how to use query store in specific scenarios we refer to here. And the last tool I would like to highlight is the Optimization Advisor. It's a little bit different tool than the previous one. This is more towards business users, and this tool is also inside Dynamics 365 for finance and operations. So this is typically used to identify and act on opportunities to optimize business processes. So Optimization Advisor just runs as a batch job on the iOS. And typically you have a set of rules. We come up with standard rules, and then you can customize and create your own rules. And these rules can then run at specific times, do a diagnose, and you could even have some automated actions out of this. So we have a specific workspace in Dynamics 365 for finance and operations, the Optimization Advisor workspace, where users then can see the opportunities that are only relevant for them, and they can then take certain actions. This is just a slide with a few examples of rules and opportunities that we have. So, for example, schedule a periodic batch job history cleanup, which is it's a popular one, and actually I advise everyone to start thinking about how to clean up data, and one that we see a lot of times as one of the biggest tables in live environments is the batch history table. It can cause also performance issues. Keep that in mind. And there are also other more functional rules, like you can see here. So the ask is here that you start making you familiar with this framework, and that you also build your own rules, because it can really help you to optimize configuration, optimize your business processes and your recurrent activities. We will not go deeper into this because there's already a TechTalk available on the Infopedia website. I put a link here, which will give more details into this tool. And there's, of course, also a docs article. So with that, I would like to thank you very much for your attention. We had a lot of questions which were answered during the session by my colleagues. Let me have a quick look. I don't think we have that many standing out. We will still stay the team here to answer the remaining questions, so bear with us a few moments after we close the session. I would like to thank you and wish you a nice day, evening, and later on a weekend. Thank you. Bye. Back to you, Janice.
All right, thank you, Davy. All right, ladies and gentlemen, I'd like to take a brief moment here and bring your attention to a link that I just posted in the Q&A panel. That's a link to a short survey for this website or web conference, and we ask that you please take a moment before logging out to access it. We hope that you found today's information helpful, and if you enjoyed today's web conference, have feedback on how we can provide you with a better event, or you'd like to submit topics for future web conferences, this is your chance to let us know. The survey scores are on a scale from 1 to 5, with 5 being the highest score possible. And that is going to conclude today's web conference. Attendees can access the web conference recording by the same registration link that was used to attend today's live broadcast. I'd like to extend a big thank you to our presenters, Davy, Jeff, and Markus, and thank you, audience, for logging in and joining us today.